This is Engineering 126, Lecture 3. So today, we're going to start looking at slightly more complicated C++ programs. Last week, if you go back and review what we did, we looked at a very simple program where we did some very simple calculations. Namely, we took 2 points in 2D coordinate space, and we calculated the distance between those 2 points. Okay, so in a program like that, everything is very linear and sequential, meaning there's a very distinct order in which we write our C++ commands. And if you might remember, in every single program that we write, we have to define every single variable that we're going to be using. So you think ahead, right, and come up with a list of every single number, every single bit of data that you're going to be working with in your program, and you come up with a name for it. These are what we refer to as variables. And we have to give each variable a type, meaning we have to tell our program whether that data is going to be an integer, a real number, and then in certain cases, maybe a character or even a Boolean. Probably the rest of all the programs we're going to be working on, we're going to deal almost exclusively with integers and real numbers, which again are called double, right? They have to type double. So we're gonna pick up where we left off last week. If you look at my lecture notes for this lecture, you'll see that I started off in those notes with what is called algorithm design. I'm going to switch the order here and actually jump to the second half of those notes, which are the selection statements. After we're done with the selection statements and loops, then I'll go back and talk about algorithm development. All right, so let me kind of give you some motivation for why we need selection statements and loops. We're going to start with selection statements. This is just a term that people have come up with for computer programming. So just like everything else, get used to this term, but there's really not much meaning behind it other than that it's a definition. Okay, so the first selection statement we have is what is called an if statement. And what an if statement is it allows you to make a comparison. It allows your program to make a comparison between two numbers. And then based on that comparison, okay, it's going to make a decision on what it's going to do. So probably the best way for me to explain this for people who have not seen it before is to give you a very quick example. So imagine that you're trying to write a program where the person is asked to input an integer. Right? So they input an integer, and then your program is very simply going to return the result that's going to specify whether that integer is even or odd. Now, you might think that this is a very simple program, which is unnecessary because everybody can take a look at any integer and be able to tell whether it's even or odd. But just for the sake of it, just for the sake of argument, we want something as simple as possible for me to illustrate this. Okay, so let's go ahead and do that. Think about what your program would need. Okay, so obviously you start thinking in terms of what variables are needed, and that means you need at least one variable. Okay, you could give it a name, let's call it x. So you need something like an int x. Okay, I'm not writing a program yet. Okay, what I'm doing is just listing some important things that we're going to need in this program. So I need int x. Okay, and then what are you going to do with this int x? Well, you define it, right? And then you need to ask the user to type in a value for x. If you remember, that requires that you write something that's part of a cout statement because you need to give an instruction or give a message, right? So you need to say something like enter an integer. Okay? And what happens after that? Well, you need to use that along with a cin, right? Once the person sees this command, to enter an integer, they're going to type in an actual integer, and whatever value they type in gets put into this variable x. Okay? So what comes next? Well, now that your computer has this value of x, it's got to start trying to determine whether that value is even or odd. So how do you do that? You might recall I said last week that we had some basic operators in C++. We have the basic arithmetic operators, which are addition, subtraction, multiplication, and division. But then in addition, there was something called a modulus. And a modulus lets you determine whether one value is divisible by another. So we're going to use that modulus operator because when something is even, it's divisible by 2, right? If it's not even or odd, in this case, then it's not divisible by 2. Okay, so all we need to do, and I'm not going to write this exactly as a C++ command yet, right? I'm just going to say we need to check if your value of x, right, and its modulus with 2 is equal to what? Remember how modulus works? Modulus says you take x, you divide it by 2, and then get the remainder, right? So if something is divisible by 2, then what is the remainder? The remainder is 0. So we're going to check if x modulus 2 is equal to 0. If it is, I'm going to say if yes, right? Meaning we're going to ask, is x modulus 2 equal to 0? Right? If it is, then we output some message that says, yes, your value is divisible. If not, we see out some message that says, no, your value is odd, right? It's not even, or something along those lines. Okay, so this is why we need to be able to check, right, and compare two different values in C++. In programming, a lot of times, your program has to make a decision based on certain conditions, on certain values. Okay, we call these comparisons. We say that if the comparison is true, then your program is going to do one thing. If your comparison is false, then it does something else. Okay, so the if statement is the way for us to do this, to make this type of a comparison in C++. Okay, so now let's go ahead and write this as an actual C++ program. Okay, so I've brought up Visual Studio. I've already got it all set up. Okay, sorry. I've got Visual Studio already all set up. And I'm going to go ahead and type in this program. So think about the elements of a program now. Remember, you start off with all your include statements, right? We're going to be asking the user to enter in a value, and we're going to be outputting results. So what included libraries do we need? If you remember from last time, okay, that is our standard input and output library, which is our IOStream library. Okay? Do we need CMath like we did last time? If you remember, CMath allows you to do things like take square roots, right? Raise numbers to powers, allows you to do trig. So in this case, we actually do not. Okay? The basic operators, addition, subtraction, multiplication, division, and modulus, are not included in any library. They're built right into the lowest level of C++. Okay, so IOStream is the only library that we need. And if you remember, anytime you include a library, you need this line that says using namespace standard, okay, with a semicolon. And now we begin with the actual program itself. If you recall, that starts with integer, right? Main. We said that this is necessary in every single program that you write. Okay, and then the whole program is going to go inside these braces. You notice I am not indenting. Okay, I'm just hitting the enter key after every line that I type, and this program is putting in all the indents for me. Okay, that's why I was saying earlier, in the previous lecture that don't try and outsmart this text editor. Okay, it will do everything for you as far as formatting goes. So just let it do its work. Okay. Remember, inside these braces, the very first thing you need is to define all your variables. And we said that the only one we need is int x. Okay? Then we're going to start asking the user for some value. So cout, I'm going to say enter a value. Let's say enter an integer. Okay? In quotes, which means everything in the quotes are going to be displayed right on the screen. Cn x says whatever value is typed in, right, x is going to be set equal to that. And now this is where we're going to check. Okay, so this is how the if statement works. We type in the word if, remember it has to be in all lower cases, and then the values we're going to compare are inside parentheses that come right after the if statement. Okay, so our comparison here is we're going to check if x and the modulus with 2 is equal to 0. I purposely typed this incorrectly, okay, because I wanted to illustrate something for you here. When we make a comparison and we're checking whether two values are equal to each other, okay, you do not use a single equal sign. What is the single equal sign used for? A single equal sign is used to assign a value to a variable. So if I create some variable a, and I want to set a equal to 5, then I say a equals 5 with a semicolon. If I am checking whether this value, x modulus 2, is equal to 0, C++ says you have to put in two equal signs. Okay, notice what I just did there. All right. Now, the if statement, okay, when you make that comparison, this is one of the rare cases in C++ where you do not put a semicolon, because the if statement, the if command, is not over after this line. There's more to this, okay? And what we normally do is I'm going to hit enter and put in another set of braces, okay? So everything that's going to happen if this is true goes inside these braces, okay? So this is how that's going to work. And what did we say we were going to do if x modulus 2 is equal to 0? If it is equal to 0, or if it's true, right, then we know that x is even. So what we want to do here is just see out some statement that says x, or in fact, right, let's not even do that. We want to display the actual number x itself. So if you might recall how you do that, right? You put in x directly, then I'm going to put in less than again, okay? I'll put in a space, because that value x, right, I want to have a space between it and the message that comes after. And then this is just going to say is even, okay? And if you remember, what I would like to do is put in an end L at the end so that the cursor goes to the next line. All right. Now, what if x is odd? Well, the way we're going to do it here is I need to check again. Okay, I haven't shown you how to simplify this yet, so I need to make a second check, because if x is not even, right, and I just run this program as is, then nothing happens. There's no message that says x is odd. So I have to allow for the cases where x is odd, which means I'm going to put in a second if statement. I'm going to say if x modulus 2. So let's do it this way. There are several ways of doing this. Okay, if something is odd, right, what is its division with 2 going to give you as a remainder? It's going to give you 1. Okay, so my second if statement here says if x modulus 2 is equal to 1, now I'm going to see out, right, x and then is odd. Okay, very similar to the even case with an end line. You notice I'm not even putting in any spaces, and this program is just formatting everything for me by putting in spaces between words to make things easy to read. Okay, And this is all I need for that program. Remember how we end our program from last time? I'm going to do a return 0 with a semicolon. Okay? So that's how, that's just all you need for this program. Okay? So let me show you how this is going to work. Let's go ahead and run it. Debug, right? Start without debugging. This is basically asking me, do I want to compile and then save anything that hasn't been saved? So I'm going to say yes. Okay, now it's starting to compile. You see this little window on the bottom here? That's where it's going to give me any error messages during the compilation if there are errors. But you can see it says 1 succeeded. That means there were no problems. All right, and here's the result. Right, I get this little window that pops up that says enter an integer. So let's put in something that's even. Right, let's say 8. I put in 8, enter, and this tells me 8 is even. Okay, let's run it again. Debug, start without debugging, and now that it's compiled, I don't have to go through that whole process again. Right, it automatically reruns the program. Now we're going to put in something that's odd. Let's say 7. This says 7 is odd. Okay? All right, so let's go back. This is how the if statement works then. Okay? What we call that check or that comparison inside the parentheses is a condition. Okay? So the way you write this, you put in the word if. Within these parentheses, you put in condition. All right. And you notice there are no braces in this example, in this illustration here. The reason for that is C++ allows you, if there's only one line, only one command that you execute when that if condition is true, then you don't need parentheses. You don't need braces. I'm sorry. Okay, so let me make that a little clearer. So C++ says you have your if statement, you have your condition, whatever that might be. In our case, that was x modulus 2 equal to 0. And then if there's just a single command like we had, then you could simply put in that one command, right? I'm not putting in all the details here. And that's all you need, okay? But if you have multiple commands, then you must put a brace, and then you have all your multiple commands, and then you end it with the closing brace. What I tell students is, why remember two separate rules, right? Why remember, well, if I have just one line after the if statement, I don't need braces. If I have more than one line, I'm going to put braces. Because you should always just stick with the most general case. The most general case is if you have more than one line. So I always tell students, always just put in these braces. Okay, I'm not saying it's a must, but it makes things a little easier to remember, right? Always just remember, if statement, put everything in braces right after that. Okay? So that's how the if statement works. The next thing I want to get into, okay, related to the if statement is what kinds of comparisons can you make? Right? What are the questions that you could ask as part of this condition? C++ allows basically any type of a mathematical condition. Okay, so we already talked about the equal to comparison, right? Checking if something is equal to each other. But here are all the others. Okay, you could check whether one value is less than another value. You could check whether a value is less than or equal to. In C++, basically, from your keyboard, right, the less than or equal to symbol is a special symbol. You can't easily type that in. So in C++, we just type less than and then followed by the equal sign. Okay, you could do greater than or equal to. There's the equal to, and then you could simply ask if something is not equal to something else, right? The not symbol, the symbol for not in C++ is the exclamation point, okay? And what that means is you could actually put the exclamation point in front of anything more or less that's on top here. I could ask if something is not less than or equal to, for instance. Okay, not that you would want to do that, but you can. Okay. All right. Now C++ also allows you to combine two conditions into one. Okay. A lot of you might remember, probably when you took took an algebra class, that there are these operators, if you will, referred to as and then or. So and or, okay, are given by these symbols here. And is 2 ampersands. Okay? Or is 2 vertical slashes. All right? So how do I type in 2 vertical slashes? If you look on your keyboard, okay, the button usually that's right above your enter key gives you a slash, a // and then when you hold down the shift key and hold that and type that key, you get the vertical line. Okay, so you need to enter in 2 of that. Let me see if I could bring up a virtual keyboard here. It's a little small, but this is actually not laid out the way most keyboards are laid out. So I'm sorry, let's not use that. Okay. Anyway, on most keyboards, right, it's the key right above the enter key. All right. So how do these things work? The and the or comparison operators. So here's a good example. Okay, if you look at my example here on the bottom, I say x is 5, y is 6, z is 7. Okay, and now we're going to ask, is x less than y and y less than z? So whenever you use the and comparison, okay, both parts must be true in order for me to say that this whole statement is true. So in our example, let's ask ourselves, right, is x less than y? Is 5 less than 6? Yes. Right. Then you have to ask yourself, is y less than z? Is 6 less than 7? Yes. So the first part is true, 5 is less than 6, and the second part is true. 6 is less than 7. Therefore, this whole thing is true. Okay. Now let's look at the second example. This is asking, is x less than y and y greater than z? Well, based on what we just did on top, we know the first part is true, right? 5 is less than 6. But we know the second part is not true, right? 6 is not greater than 7. All right? So one is true. One part of this is true, the second part is false. Remember what we said? In order for an and comparison to be true, both parts must be true. So the fact that the second part is false means this whole thing must be considered false. Okay. The or operator is a little different. When you do an or, only one part needs to be true for the whole thing to be true. Okay, so now if I replace that second line, the 2 ampersands by the 2 vertical slashes, now that's an or. So if I ask, is x less than y or y greater than z? Then this becomes true, okay? Because only the first part is true, but as long as the first part is true, then the whole thing is true, okay? And then notice I could take that whole thing and put a not, put an exclamation in front of it, right? Make sure you use parentheses, otherwise, you know, order of operations, right? It could get misinterpreted. But if I put a not in front, then obviously the whole thing becomes false. Okay? So when do you use this? Let me give you the best example for when you use the AND comparison. Let's say you're checking whether a number falls in between two quantities. So let's say I want to check whether some variable x, right, is between, let's make up some range, 10 and 20 inclusive, let's say, right? Well, C++ will not allow you to do this. I cannot do this in C++. I cannot say if 10 less than equal to x less than equal to 20. Okay? C++ won't allow for this. See, remember, computers are very strict, right? They follow very strict rules. So if I put in something like this, the computer just gets completely confused, right? It needs to be told one thing at a time. It has to look at one thing at a time. So if you want a computer to be able to analyze whether x is between 10 and 20, okay, you need to break it down. And how do you break it down? Well, if you have a value x that's going to be between 10 and 20, then it must be greater than or equal to 10, and it must be less than or equal to 20. Okay. Now, why do I say you have to use the AND? Why not OR? So let's look at an example, right? If I have the value 30, right? Is 30 greater than or equal to 10? Yes, right? But is 30 within that range between 10 and 20? It's not, because 30 is not less than or equal to 20. Okay? So what I need for the value of 30, what I need is basically the AND comparison, right? So how about if I have a value that's 5, right? Is 5 less than or equal to, is 5 greater than or equal to 10? It's not, right? Even though it is less than or equal to 20. So that's why now if I have a value like 15, which does fall into this range, then I can say, right, 15 is greater than or equal to 10, and it's also less than or equal to 20. So how do I write that? I'm going to do this. Look carefully here. Okay, this is exactly the way you should do it. I'm going to say if, right, the first comparison is to check whether x is greater than or equal to 10. So that's a separate comparison in itself. I'm going to put separate parentheses. X greater than or equal to 10. Okay? And then the second part of this, I need to link them together with the AND. So two ampersand symbols. Right? The second part is to check whether x is greater than or equal to 20. X is less than or equal to 20. Okay? So x less than or equal to 20. And then make sure you close all your parentheses match up. Okay, so that's how you do the comparison. Okay, check whether something is within range of two values. All right, so I don't think I need to come up with an example for OR. Right? Well, if something comes up where we need the OR, we'll get more into it. But this is the most. You're going to see this over and over, right? Checking whether a value is within some range. So the AND operator is used quite a bit more than the OR operator, okay, especially when you're writing math programs. Okay, so that is our if statement, right? And those are all the things that you can do in the if statement. So let's move on. Okay. There is something, the next level up from the if statement is what we call an if-else statement. So let's go back to our example. Let me bring up my program here, right? So we were trying to check whether this value x is even or odd. And the way we did it by using those two if statements is actually very inefficient, because I first had to check whether x was even, right? And then even if it is even, I go ahead and check whether it's odd. Now, we know once something is even, then there's no way it can be odd. So I'm doing extra work. I'm having the computer actually do extra work. Okay? Now, if the number is odd, then I went ahead and checked whether it was even first, and I know it's going to not be even, so then I make the second check whether it's odd. So regardless of whether that number is even or odd, I'm checking, right, both conditions, whether it's even and then whether it's odd. Okay, so there's the inefficiency, because I have to check both cases no matter what. So the if-else statement, okay, lets you make it more efficient by doing only one check. Okay, so the if-else basically says you first check the if, right, is x even. If it is, you go ahead and do what's inside those braces. And then, then there's the else, which means otherwise, right, if the first part of it is not true, do the second part. So notice there's no check there, right? I check whether x is even. If it's not, then automatically it goes to the second part. It goes to the else part. All right, so the syntax, or the way you write out the if-else, okay, is like this. You have the if. Okay, let me use the box on the right. Remember this whole idea with the braces, right? Let's stick to the version with the braces. So I check my condition, right? If something is true, and then if it's true, I do everything that's inside these braces here. Then I put in the word else, and then I put in the alternate statements down on the bottom. Okay, so that's how if-else works. Let's go ahead and rewrite our C++ program, okay, to work with if-else. So I have my first if statement, right? I'm going to leave that as is. But this second if, okay, I'm now going to take out and put in the word else. It's literally that simple. Seems like a very minor change, right? And you won't notice a difference in how fast this program runs. But, you know, this is more efficient. And let me just talk very briefly about why this is more efficient. Okay. Computers are great at math, right? Computers are good at doing arithmetic. They're very good at making these comparisons, right? Taking two numbers and comparing one is greater than the other, whether two numbers are equal, and so on and so forth. So computers are great at that. But doing anything like that, where you're comparing and where you're doing arithmetic, okay, it takes up resources, okay? It uses up processing power. And the more of those you have in your program, the slower your program runs. These days, our computers are so powerful that it really has no effect, right? Not unless you're writing a very, very complicated type of program. But in the old days, right, I'm talking 20, 30 years ago, when people first started programming, right, on the desktop, computers didn't have this power. If I were to run that previous program compared to this program now, meaning two if statements versus the if-else, then I would actually know there's a difference in how fast the program runs. Okay, simply because when I put in the two if statements, it was making an extra comparison, which means it was doing an extra process. If you remove the second if with an else, then think about it, right? How many comparisons are you really making? You're making just one comparison. You're asking, is x modulus 2 equal to 0? If it is, boom, do the first part, it skips the second part completely. Okay? If it's not, it didn't have to make a second comparison. It just jumped right to the second part under the else, and it did what's inside there. Okay? Whereas before, with the two if statements, it had to check, right, whether x modulus 2 was equal to 0. Even if it's not, it went ahead and checked if x modulus 2 was equal to 1. Okay, so that's inefficient. Now, these days, right, does it really matter? If you had a program, right, if you were writing a program for yourself, just trying to solve some kind of an engineering problem, does it matter if you put in two if statements instead of an if-else? No, okay, it really doesn't make a difference. Now, if you were a professional programmer and someone was hiring you to write a program, then they expect you to make that program as efficient as possible. So that's where it would matter, okay, if you were a professional programmer. So for the purposes of this class, I mean, I want you to know the difference between the two versions, but I don't care which version you decide to use. Okay? Later on, we're actually going to have a bunch of ifs or a bunch of if-elses, and if you put in a bunch of if-elses, that's going to be much more efficient. Okay? But for the purposes of this class, if you want to put in 10 if statements, it doesn't matter. Okay, I'm okay with that. You should be okay with that. Right? If you end up getting a job with Google or Microsoft, then it does make a difference, and you are expected to be as efficient as you can. Okay, so let's continue on. So the if-elses are great. Okay, now the next step beyond that, okay, is checking a bunch of conditions now. Now I have a bunch of possibilities, okay? Now I don't have just two possibilities. It's not just even or odd, okay? I'm gonna have a bunch of possibilities. So let me give you an example here that I like to use. The example that I use, okay, is I want to write a program that's going to ask me to enter in a number grade, right? Some number between 0 and 100, okay? And then based on that number that's entered, this program will tell me whether that grade corresponds to an A, a B, a C, a D, or an F. Okay? Simple enough, right? I think everybody should know exactly what I'm referring to here. Right? So let me just kind of lay out what exactly we're going to do. We're going to have, again, think ahead for yourself. Right? How many variables do you need? At the very least, you need a variable for this grade, this number that's going to be entered, right? And, you know, depending on the situation, a lot of times grades are just integers, but some professors might use real numbers, like they might give partial points, right? So you could end up with a grade that's like 85.5 or something like that. So it's up to you. I mean, for the sake of simplicity, let's make it integer again. All right, so I'm going to have an integer. Let's call that, I'm going to call it number, right? Or num. That's good enough, and meaning it's a number grade, right? And then you're going to see out, right? Ask for the person to enter in the grade, enter number grade. Okay, then you see into num. So you should be getting very comfortable with this idea of the see out followed by the see in now, right? Every time you ask someone to enter in a value, this is input output. And then we're going to start checking whether this number is within a bunch of different ranges. Okay, so why don't we work our way down from A all the way down to F. And now I'm going to stop writing code. Okay, we'll get to the code part later. So the first part is checking for an A. You want to check if your number, all right, let's make a list for ourselves. For A, we want to check if our number is greater than or equal to 90. Everybody agree? Okay. For B, B is between an 80 and an 89, right? So we want to check if 80 is less than or equal to our number, is less than or equal, or we could say, you know, there's two options here. Why don't we just say less than 90, right? Anything that's less than 90, let's say, is a B. Since we're dealing with integers here, right, let's not get into, you know, 89.7 is an A, right? Let's not get into that. All right, and then C is between 70 and 79, so I'm checking if 70 is less than or equal to number, is less than 80, right? Then D is between 60 and 69, so 60 less than or equal to number, less than 69, less than 70. Okay, And then f is anything below that, below a 60, right? So num less than 60. So that's what I'm asking. I'm asking all these questions. Okay? Can everybody see that you could do this with a bunch of if statements, right? I could do an if, right, and ask, is that number greater than or equal to 90? If it is, print out some message that says that grade is an A, right? Then you go ahead and check, is that number between 80 and 90? If it is, print out some message that says that value is a B, and then so on and so forth. Okay? So you could do that definitely with a bunch of if statements. So let's go ahead and type that in. Right? We have our C++ Visual Studio here. I am going to go ahead and now start deleting a bunch of stuff. Okay? I could reuse some of this. So I'm just going to retype some of it. Instead of x, we called it num, right? And then we said enter a number grade. Okay, then we cin to num, and then we checked. Okay, this is the first check now, whether that value is an A. So if num, okay, we don't worry about modulus anymore. What we're checking is if number is greater than or equal to 90. Right? If it is, what do we say? We see out. Grade is A. Okay. End line. Then the next step is to check if it's a B. Now B, we said it's between 80 and 89. Remember how you check something within the range? We just did earlier, right? The AND comparison or the AND condition. So let's go ahead. This is going to be if, okay, num is greater than or equal to 80. I need my extra parentheses. Notice you don't put 80 is less than or equal to num, right? Your variable, if you're comparing a variable to a number, that variable is always on the left-hand side, okay? And then the second part of this comparison is that number is less than 90. Okay, so there's the comparison. If that's the case, I'm going to see out grade is B. End line. Okay, and now the next couple of these are very similar to that. So I'm going to copy and paste here. Okay. Control C, Control V, and now I just replace these numbers, right? For C, it's between 70 and 80, right? And now grade is C. I'm going to copy and paste again. Okay, and now this is for D is between 60 and 70. This D. Okay. And the last one okay. Sorry, didn't paste. Okay, the last one is F. So that's just anything that's less than 60. So if num is less than 60, right, grade is F. Notice what happened here. I typed over something and I didn't hit the enter key. So this did not automatically format. Okay. So let me tell you a little trick here. A lot of times students will go ahead and they forget and they try and outsmart this text editor, right, and try to do their own formatting, and then everything gets confused. And when I'm trying to read their program, it's just difficult to read because things are all over the place. There are no indents, right, or there are weird things going on with the formatting. A lot of times what I want them to do is convert it into a form that looks exactly as if they just used the formatting that's provided by the text editor. Right? So you can ask the text editor to do that for you. What you do is you just select everything. Actually, you don't even need to select everything. Right? You go to Edit on the menu up top. Okay? Then you go to Advanced, and you just say Format Document. And that will format everything correctly for you. Right? Now, obviously, this is mostly formatted correctly, so nothing really happened. All right, so I've got my last if statement, right? And that's the end of the program. So I'm just going to return 0. And now let's go ahead and run it. Debug, start without debugging. Yes, I want to build it, right? Build it means, again, compile it. All right, so here it is. Enter a grade. Let's run this a few times with a bunch of different cases, right? So let's say I put in an A, right? 97. Grade is an A. Okay, let's run it again. Control F5 doesn't work for me, as we said, but yeah, it doesn't work. Okay, that's my volume. Let me see. Maybe it's function on this computer. No, it didn't work either. Oh, it does. Okay, so on my computer, it's a function F5, not a control F5, so that's good. Although now it's running some diagnostic tools. Okay, doesn't matter. So let's do B, right? B, let's say 82, right? Grade is a B. That actually didn't work exactly the way I wanted it. All right, it looks like I have to run it from the menu. Okay, start without debugging. So the B case, it just kind of went away, right? So let me mention briefly why that happened. When you hold down Control and F5 to run your program, to compile and run your program, the control, holding down the control along with the F5 basically says run the program, and after the program is done running, do not close this little black window that pops up, okay? If you don't hold down the control key, if you run your program by just hitting F5, right, which is essentially what I did just now, then that tells your computer, run the program. As soon as the program is done, close the window. So you basically see something that flashes and then disappears. So you can't really see what the result is. Okay, so you always need to hold down Control and then hit F5, on most computers at least. All right, so let me redo that B case, right? So grade 82, you see grade is a B. All right, let's run it again. Okay, debug, start without debugging. Let's run a case for C, 76, right? Grade is a C. Debug, start without debugging, right? 63, grade is a D. Then for F, right, let's put something really small here. Why don't we say 20, whoops. 24. All right, grade is an F. So can everybody see that this program worked exactly like we wanted? Okay. Now, let's take a look at this program in a little more detail. Okay. We've used how many if statements here? 1, 2, 3, 4, 5. 5 if statements. Every time you run a bunch of these if statements, right, what has to happen? It has to run through every single one of them. So in our first case, when we put in a grade that was an A, let's trace through what happens here. My computer runs, my program runs, it's checking here, right, if my number is greater than or equal to 90. In our case, it was, so it went ahead and did this cout, right? It gave me the message, grade is an A. But then it had to keep going. Now it had to check. It's the number between 80 and 90. In our case, it was no, so it never ran what's inside the cout, right? It never ran the cout statement, but it had to keep going. It went down to here and checked if our number is between 70 and 80. It was not, but it still had to run through this, and then it skips the cout, and then finally it checks. It checks one more time. Is our number between 60 and 70? It's not, so it skips that cout. And then finally, it checks if our number right, was less than 60, and then it was not, so it skipped that last C out. But you see what happened, okay? Even though, you know, if you were doing this yourself, if you're doing this by hand, once you determine that a grade is A, then it can't be B, C, D, or F, right? So ideally, once you found out that that grade is A, you should have skipped all those other ifs. You shouldn't need to check whether it was B, C, D, and F, right? But the way this program is written, the computer still went ahead and checked, okay? So that's the disadvantage of using a bunch of these ifs when you're making a bunch of different selections, all right? So how do you do this more efficiently? You could do it more efficiently with if-else, but the way we discussed it earlier, right? If-else allows for an either-or situation. This is not an either-or situation. This is saying pick from among 5 different scenarios. Pick from among 5 different possibilities. You're not picking between 2 possibilities. You're picking between 5 possibilities. Okay? So the way we talked about if-else wouldn't work in this case. But, okay, we can make it work. And the way we do that, we make it work is to do what we call a nest, or to nest if-else statements. Okay? So let me see if I can explain what nesting the if-else statements really means. In our case, right, here's what we do. We first check, is our number greater than or equal to 90, or is it not? Right? So you just do an if-else. If our number is greater than or equal to 90, then you just say, print out, okay, greater than A. But if it's not, then we go to the else. And what's going to happen inside this else, okay, is we check again. We're going to check if our number is between 80 and 90, okay? If it is, then we simply go ahead and print out that it's a B, I'm sorry, right? But if it's not, then we go into another else and check whether that value is between 70 and 80, or a C, right? If it is, we print out the message that it's a C, but if it's not, then we go to another else, okay, and then check there. So here's what we do. Let me see if I can lay this out for you. Okay, so I start with an if. All right, we're going to say if our grade, or num, is greater than or equal to 90, right? If it is, I'm just going to do, let me leave out, you know, some details here. It's just some C out, right? C out A. And then inside this else, okay, I'm going to check again. I put in another if. I'm going to check if num is greater than or equal to 80. Okay, and actually that's all I need. So here's the advantage. Let me get rid of one parenthesis. Look at this. Notice I don't need to check whether it's between 80 and 89. Why not? Why do I not need, let me put it back in. Why do I not need and num less than 90? Why do I not need that? The second part. Think about that for a minute. So if you said, right, that once you get inside this else, there is no possibility that your number is greater than 90, then you would be correct. Think about what happens. Right? Start at the very top. Okay? Let's say you put in the value 87. Let's say the number is 87. Right? So it first checks, is 87 greater than or equal to 90? No, right? We're going to skip what's in here. So it goes to the else. Within that else, right, what does that mean if you're inside this else? It means your number is already not greater than or equal to 90. That means your number is less than 90, right? If you find yourself inside this else, you already know your number is less than 90, which is this, right? So you don't need that anymore. Now you only need to check if your number is greater than or equal to 80. If it is, you see out, right, B. And then you put in an else here. So this is why this is called nesting. I have this set of if-else's nested inside the very first if-else. Okay. And then within this else, what do? You check if your grade is a C, right? If num is greater than or equal to 70, right? And you could imagine what goes on. All right. So let's go ahead and modify our program. All right. So we don't need to do any excessive typing here because a lot of this can be reused. Okay. So there's the first if. If number is greater than or equal to 90, right? We see how great is an A. But now I'm going to put in an else. All right, else, and let me just hit the delete, bring this over. Else, sorry, the else needs its own brace. Okay, so let me put in my brace. Else, sorry, else, right? And remember, we don't need the second comparison. So else, I'm going to check if number is greater than or equal to 80. Right? If it is, right, I am going to see out grade is a B. Else, I'm going to check if grade is a C. Okay, so just follow along here as I modify this program. Okay, see if you can catch exactly everything that's going on. Grade is a C. Okay. Grade is a C. Else. This part is grade is D. Okay, and do I need another else? I mean, do I need another check here after this? All right, oops. So look what happens. This last case here is if number is greater than or equal to 60, your grade is a D, right? But then what's going to happen inside the else that goes along with that? If I get all the way to this point, to this last else, right? That means my grade is not A, B, C, or D. What's the only possibility that's left? It's F, right? So do I need another if here? The answer is no, okay? This very last else is simply going to say grade is F, okay? Nice and simple. All right, and then let me just close out that brace. Okay, I've got to close out. Make sure, be careful here. All your braces have to match up. Okay, that's why you should accept the formatting that that this program gives you, because it will make sure it indents everything, and then you can match everything up. Okay, but you have to be very careful here. All right, you notice these two match up, these two match up, these two match up, right? These two match up, then these two have to match up, and then this has to match up with the one all the way up on top. Okay? So what is so different between this and the previous case where we put in 5 separate if statements? Well, this is actually much more efficient now. Okay? First of all, the very first thing, right, that makes this more efficient is instead of those ifs, and within a bunch of those ifs, if you remember, we're actually making 2 comparisons. There was that and, right? A lot of those ifs had ands. Now there are no ands, so all you're doing is making single comparisons, right? Is your number greater than 70, greater than 60, greater than 80, greater than 90, right? Less than 60. Those are the only comparisons you're making. You don't need those ands anymore. So that by itself already is fewer comparisons than in the first case, right? But let's see, let's kind of trace through a couple of examples here. Let's say our grade is an A, okay? So I put in a grade, A, right? And so we're here in this program. I put in a grade of A, right? It could be like 97 or something. So it's going to check. Is that number 97 greater than or equal to 90? It is, right? So it goes right to the cout. And what does the if else really mean? It says if you're running what's under the if, then you completely skip what's under the else. And what is under the else? It is all of this. All of that stuff that's from here all the way down basically to the end of the program. I'm skipping all of that stuff, all of this, okay? All of this, all the way up is skipped, okay? So all I need to do if I have an A is the computer makes one comparison and then it disregards all the rest, okay? Now let's look at a case where you have a B, right? Maybe my grade is, let's say, 83. So if I have an 83, the computer comes here, it checks. Is 83 greater than or equal to 90? No. 83 is not greater than or equal to 90, so it's going to skip this cout, and it's going to go into the else. Okay. Now, inside this else, it's going to follow everything in sequence first, right? So it's going to check. Is that number 83 greater than or equal to 80? It obviously is, right? So it's going to do what's inside the cout, what's inside the braces here, which is the cout, grade is B, and then it's going to skip all these else's. And what's included in that else? It's everything from C all the way down to F, okay? So I skip those comparisons. Now I'm making 2 comparisons as opposed to all those many that we did in the previous case with the 5 if statements, okay? So what is the worst case scenario when you write this program with a bunch of these nested if-else's? The worst case scenario, as you've probably figured out, is when you have an F, right? If you have an F, okay, let's see what happens. So I put in a 23, right? My grade is a 23. I'm going to check. Is 23 greater than or equal to 90? No, right? So I skip this cout. I go under the else. I check. Is my 23 greater than or equal to 80? No, right? So I skip this cout. I go to this else. I check. Is my 23 greater than or equal to 70? No, I skip that cout. Go to this else. I check. Is 23 greater than or equal to 60? No, right? So I skip that and continue on down to this very last else, okay? And then it just says grade is an F. I'm sorry, we compared it. It's not greater than or equal to 70, right? So we skip this grade is C. We go to that else. We check, is it greater than or equal to 60? It's not, so it skips that, but goes right to this else, which says grade is an F, okay? So what is the worst case scenario? The worst case is you make 4 comparisons, right? We checked whether our number is greater than or equal to 90, greater than or equal to 70, 80, greater than or equal to 70, and then greater than or equal to 60. That is 4 comparisons as compared to the very many that we had prior. Okay, so it's a huge difference, actually. right? So if you count how many comparisons an F would have required, all right, or actually how many comparisons any grade would have required when you use 5 if statements, let's count them. Okay, here's one comparison. I need to check whether my number is greater than or equal to 90. There's 2 comparisons here. I need to check whether the number is greater than or equal to 80 and then less than 90, right? 2 comparisons here, 2 comparisons here, 1 comparison here. So you need 8 comparisons no matter what your grade is. It could be A all the way down to F. No matter what, you have to make 8 comparisons, right? In the new version of the program, the one we just typed, right here, best case is when you have an A, right? That's 1 comparison. Worst case is when you have an F, that's 4 comparisons. Even the worst case is better than using 5 if statements. All right? So this is the preferred way of writing a program like this. Okay, so review it. Make sure you understand exactly what's going on here. If you have questions, feel free to email me. Okay. Now, again, if I gave you this as an assignment, do I care in which way you write it? Doesn't matter with your very powerful computers whether you use 5 if statements or whether you put in these nested if else's. The answer obviously is no, it doesn't make any difference. Okay, you could go ahead and time how fast your program runs using both cases, and you won't be able to tell a difference. Okay, it might be like a tiny fraction of a second, simply because our computers are so powerful. Now, if you were to go ahead and run this on a computer from 25 years ago, you would be able to tell a noticeable difference. All right, so before I go on to the next part, let's just run this, right, this modified version of the program, so people can see that it still works. Okay, it should work pretty much the same way because the improvements happen in the background, right? As far as someone running the program is concerned, there's really no difference. Okay, so let's build it. Let's go ahead and run it. All right, enter a grade. All right, 98. Grade is an A. Okay, then we don't need to run every case. Let's just run case with F, right? 23. Grade is an F. Okay, so it runs exactly the same way. All right, so let's move on. So these are still selection statements. Okay. And selection statements lets you choose, remember, among a bunch of different possibilities. All right, now there is one more selection statement that you should know how to use. Okay, that is what we call the switch statement. Okay, so the switch statement actually works very similarly to a bunch of ifs or a bunch of nested if-else's. The only difference is in the switch statement, you have to, the switch statement only allows equal to comparisons. Okay? So in that example we just did, where we were checking whether a grade was A, B, C, D, or F, you would not be able to use the switch statement. Okay? The switch statement works, again, when those comparisons are equal to values, okay, or equal to comparisons. So the way this works, okay, is you first put in the word switch, and then within parentheses, it's your variable. It's the variable that you're comparing. Okay, thanks to. So whatever is this word expression, like it could be your variable num or variable x, whatever your variable is, right? That goes in here, and then you have a bunch of cases, right, or a bunch of different values that your expression can possibly have. And then within each case, right, you have a bunch of statements. So what is an example of this? Okay. And notice that there's a default. This default basically says if it's not any of the values up above, then execute whatever is under the default. So let me see if I could give you an example of this. Okay, so I've got some variable and it could take on certain values here. Let's see. Let me come up with a simple example. Okay, so maybe we have some kind of a menu, right? You ask the user. So a lot of times you write a program, and then that program allows for a bunch of different types of calculations. So let's say you ask the user to choose whether they want to do a simple addition, a simple subtraction, right, multiplication, or division, right? So you ask them, and then you give them a choice, right? Because how are they going to tell the program whether they want to add two numbers together, subtract two numbers, multiply, or divide two numbers, right? You have to give them a choice, and then, you know, just give them something like a menu, right? When something is text-based, then your menu is going to be in the form of having them type in either symbols or typing in numbers. Okay, so let's say you use numbers, right? And so what you do is something like that. You say you have a cout that says enter 1 to add values together, right? 2 to subtract. I'm leaving out some words here, right, for simplicity. 3 to multiply. 4 to divide. Okay, or something like that. So you give them a choice, right? Enter 1, 2, 3, or 4. And then based on what they choose, you're going to do two different things, right? Now, obviously, prior to this, you probably ask them to type in two numbers, and then they choose whether they want to add those two numbers together, subtract the second number from the first, right? Multiply the two numbers together, or divide the second number by the first, you know, or something along those lines. Okay. So after they made their choice, okay, you go ahead and use the switch statement, because choice is either distinctly 1, 2, 3, or 4. Okay, notice it's not a greater than or less than or greater than or equal to, less than or equal to type comparison. These are equal to comparisons. Now, can you still use if-else's or a bunch of ifs? Yes, right? You could do something like if, right, choice is equal to 1, you do your addition, right? Then you do if choice is equal to 2, you do the subtraction, right? So you could have 4 if statements. How else can you do it? You could do a bunch of nested if-else's, right? You could do if choice is equal to 1, you do something else, right? Then you check if choice is equal to 2, you do something there, right? And then else, and so on, right? You get the idea, okay? But the easiest way to do this is with a switch, okay? You do switch, then look at your variable choice, I'm sorry, that's not a, I don't use this very often, so oftentimes I forget the syntax, right? So it's braces and then colons. Okay, so switch choice basically says, take a look at the value of this variable choice, okay, and then you have case 1. Now, case 1, 2, 3, 4 does not mean first case, second case, third case, fourth case, right? This value of 1 actually corresponds to a value that this variable choice can take on. Okay, so case 1 would be adding your two values together. Then you have case 2, right? Do something there. Case 3, do something. And notice there's a default. So since you can only have, well, actually no, let's have case 4, right? And then what if the person entered in something other than 1, 2, 3, or 4? Then you put in a default. And what are you going to do under that default? You're going to give them a message that says something like you entered in an invalid choice. All right? So let's write a program where we make use of this. So, and I'll point out something that's very important when we write this program, okay? Because I did leave out a very important detail. All right, so we're going to go to that previous program we wrote, and I'm just going to delete most of this now. Okay, we no longer need it. This is going to be a completely new program. So the way this is going to work, okay, we're going to enter two values. So let's think in terms of what variables we're going to need. We're going to ask the user to enter in two values. Okay, then we're going to ask them to enter a choice, 1, 2, 3, or 4, for adding, subtracting, multiplying, and dividing. And then we have to give them a result. Okay, so that's another value. So let's see. We're going to allow any type of numbers. All right, so let's have double. We're going to do a double. And I'm just going to call my two values A and B. Okay? Then we're going to have integer choice, right? Choice is going to be 1, 2, 3, or 4, so that could be an integer, okay? And then I'm going to go back up to this first line again, right? And let's create something called result. Result is either, based on the choice, is either going to be A plus B, A minus B, A times B, or A divided by B. All right, so we have those. We define our variables. Then we're going to do a cout. Okay. Enter two numbers. So the user knows that they need to enter in two values, right? And those are going to be A and B. And then we're going to cout, right? Enter 1 to add, 2 to subtract, 3 to multiply, and 4 to divide. Okay, cin to choice. And now, this is where before we would put in a bunch of ifs or some nested if-elses, but now we're going to use the switch. Okay, so switch. This is going to be choice. Okay, then we have our cases. Case 1, okay, is going to be the situation where we add. So we're going to say result is equal to A plus B. Case 2. Okay, and here's what I left out before. Okay, let me go back up to case 1. We have to put in break. Break says once you calculate this result, A plus B, then immediately exit the switch. Okay. If you do not, then it actually goes and just runs case 2, case 3. It'll run the rest of the cases anyway. Okay, so you need that word break. That's the important part that I said I left out. Okay. Case 2 is the one where we're going to subtract, right? So result is equal to A minus B, then I break. Case 3 is where we multiply. Okay, then break. Case 4 is where result is equal to A divided by B, and I break, right? And then we have a default, because if the user puts in, say, 5, right, that's not a valid choice, then let's put in result. Let's just like put in a 0 for now, okay? Obviously, it's not exactly the best thing to do, all right, but let's just put that in. Do you need a break for default? Okay? The answer is no, because if you get all the way down to the default, that means you're not going to skip anything, right? So I don't need a break there. And then what I do after that is I'm going to see out, okay, the result. Just put the result of your addition, subtraction, multiplication, or division. Okay, then return 0. Whoops, I'm sorry. Those are already there. Okay. All right. Okay, so see how that works. Okay, and let's go ahead and run it. Debug. Start without debugging, yes, compile it, and run it, enter 2 numbers. So if we're adding, let's just do 5 and maybe 6, right? That should give me, okay, so I'm gonna, choice 1, if I enter 1, that should give me 11, okay, there it is. Let's run it again. Let's subtract 5 and 6 should give me -1. If I subtract, let's choose 2 to subtract -1. There it is. Okay, debug. Start without debugging. 5, 6. Oops. Okay, let's multiply. Should give me 30. Divide should give me some fraction. Yes, right? 8333. And let's put in something invalid. Okay, it should give me 0. So 5, oops. All right, so 5 and 6, right? And now for this choice, I'm going to put in 5. Which is not valid. It should give me 0, because we said the default case is just give a result of 0. All right, so hopefully that made sense. Again, if there's anything that isn't clear, feel free to contact me, okay? And I'll try and work things through with you. All right, so let's go back to the slides. Okay, that's the switch statement. What comes after this? Okay, so we are done with all the selection statements, and the next thing is what are called loops. Okay, so what is a loop exactly? A loop, okay, is any time that you're repeating some command or some set of commands over and over. All right. Now, when would you ever do that in programming? If you've never seen it before, it's going to seem odd, right? Like, you might ask, why would you ever want to repeat something over and over and over? All right, so let me give you an example. If I write a program, okay, where I'm going to ask the user to enter in a bunch of exam scores because the program is going to calculate the average of all those scores that are entered in, right? Think about what's going to be done over and over and over. You're going to ask the user to enter in a score, right? So that's one thing that has to be repeated, is you're going to enter in a score. But how do you calculate an average? Once a score is entered in, right? You have to keep a running sum. Remember, an average is taking the sum of all the values and then dividing by the total number of values, okay? So that means in every iteration or every time you kind of run through your loop, right? Every time you repeat a command, what you're really doing is you're entering in the value, you're adding that value to the sum that you're keeping track of, right? And those are the two critical steps, right? Now, once everything is done, now you've got this sum that's been calculated, but what you need to do is take that sum and divide by the total number of values, okay? So that's a good example of when you would use a loop. Now, there are two different types of loops, okay, in general. In one type of loop, you know exactly how many exam scores you're entering in, right? So I know if I have 20 exam scores, then I'm going to loop 20 times. In the other type of a loop, you don't know how many times you're going to loop ahead of time. This would be the case where I've got a stack of exam papers that I want to calculate the average of, but I didn't count beforehand to determine how many exam papers I have. What I want to do is just go through the papers one by one, enter in all the values, and when I'm done, I want to tell the program, okay, I'm done. Go ahead and calculate the average of all those values that I entered. Okay? So those are the two types. The simpler type is the one where you know ahead of time how many exam scores you have. Okay? So let's talk about that type first. That type is what we call a for loop. Okay? And you're going to use for loops quite a bit. Okay? In the for loop, okay, you need to define certain things. A for loop requires what we call a counter. Okay? Let me not use the slides here. Let me do it on my whiteboard. Okay? So a for loop requires what's called a counter, meaning you need to keep track of how many times you've run your commands so far. Okay? So you need a counter. You need to specify how many times you're going to loop, right? And then you need to specify how you're going to keep track of your counter. What I mean by that is this. Usually, when you keep a counter, you just count by ones, right? You go, okay, I've looped one time, then two times, then three times, and so on and so forth. But there might be situations when you want to count backwards, for instance. Right? Maybe I'm going to start at 20 and count down to 1 or count down to 0. Sometimes you want to count by twos. Maybe I just want to go 0, 2, 4, 6, 8, 10. Right? Sometimes you want to count by 5. It doesn't matter. There are all kinds of different possibilities. Right? Now, you might ask, well, why would I ever want to count by 5s? Well, you never know. Right? C++ is flexible enough that it's going to let you do anything you want as far as how you want to count. Okay. In most of the programs you write, or I should probably say in all the programs you're going to write, it's okay to just count by ones, right? Just start from 0 or 1 and just keep counting up. That's perfectly fine. Right? You might run into a situation here or there where it might actually make things a little easier to count backwards, okay? And that's fine too. And I think later on in the semester I will have an example for you where it makes things a little quicker to count backwards rather than count forwards. All right? So that's not that important, okay? What's important is that you know how to set up your for loop. So the for loop, okay, has these three parts. And let me give you what a typical for loop looks like, and then I'll explain all the different parts of it. Okay? So you write for, okay? I'm going to create my counter. Counters are integers, right? I hope that's obvious. If you're counting, then you want to count by whole numbers. You don't count like 1.1, 1.2, 1.3, right? And you don't count 1.1, 2.1, 3.1, right? You just count using integers. So we always use an integer. You have to define that your counter then inside the for loop by the word int, right? Then you give it a variable name. Historically, people like I. So I is very common among programmers. Okay, so people would like to use I, but you could use anything you want. Come up with your own name, right? You can call it X. You could call it count, right? You could call it counter. It doesn't matter, right? Then I'm going to put a semicolon. So the first part of the for loop basically defines the counter, and it has to be defined as an integer. Okay, so int I. The second part, okay, kind of sets the limits for your counter, meaning how long do you keep counting, right? So let's say I want to count. Actually, I left out something here. So I define my counter I, but I've got to give it a starting value. Okay, and like I said, okay, 1 or 0 are the most typical values. So let's say I want to start counting from 1. Okay, so int I equal to 1. So again, what that says is create this integer counter I that starts at value 1. Okay, and let's say I want to count from 1 to 20. Right, I want this to loop 20 times. Now actually, while I'm on this topic, right, the reason historically that people like to use I for the counter variable is probably because I stands for iteration. Right, each iteration, right, basically is like one iteration is one time of repeating these commands over and over. Okay, so that's just another term that's used quite a bit in computer science, computer programming. Right, so I for iteration. All right, so int I equal to 1, and I want to count from 1 to 20. Right, so the way you're going to write that is I less than or equal to 20. Okay, with another semicolon. Let me explain this. The way a for loop works, okay, is it actually makes a check each time it goes through the loop. So here's how this works. This says set your integer I equal to 1, okay, and then check if I is less than or equal to 20. If it is, then keep continuing on with this loop. Once it's not less than or equal to 20, then stop. Okay? So we'll get more into that in a little bit, right? But if I count from 1 to 20, right, this last part has to define how I'm going to count. Because counting from 1 to 20 can be done in singles, right? And which is the most common case, as we explained earlier. Meaning you go 1, 2, 3, 4, 5, all the way to 20, right? But maybe you want to count by twos. You go 1, 3, 5, 7, right? Maybe you go by threes, right? 1, 4, right? 7, 10, and so on, right? So on and so forth. So there are a bunch of different possibilities here. Usually we're going to count by ones. So let's go and do that. Okay, the shortcut for writing that is I++. All right, so let me explain what I++ stands for. I++ stands for I is equal to I plus 1. It's a shortcut. It's a short way of writing I equals I plus 1. And I equals I plus 1, right, basically says take your current value of I, add 1 to it, and make that your new value of I. So can everybody see, right? If I have I starting at 1, the next time through, it takes that value of 1 and adds 1 to it, and now I becomes 2. Right? The next time through, it takes the value of 2, adds 1 to it, I becomes 3, and so on and so forth. Right? So just as something for your own information, right? This shortcut I++ was something that the people who invented C++ came up with, right? And they said, okay, let's use this shorthand I++. And then they said, when they were trying to come up with a name for their new language, they decided, since this is they were so proud of this shortcut, right? They said, let's go ahead and call our language C++. So what is C++? C++ is C equals C plus 1. Okay? C++ was an improvement on an old language called C. So since it was an improvement, they're like, it's like adding one. It's one better than the old language C, right? So we're going to increase the old language C by 1. We're going to improve it, and that's C++. Okay, so that's where the name C++ comes from. You know, just so for those of you that were wondering where does name C++ came from. All right, so that's how the for loop works. Okay, and let's kind of talk in a little more detail then. Okay, we're using this in the context of calculating an average, right? We've got 20 exam scores that we want to enter in, and then we want to calculate the average. So inside this for loop, okay, we put braces, and what goes inside these braces are all the commands that we're supposed to do with each time through the loop. If you recall, right, for calculating the average, what that means is we need Cn, we need to Cn some value, right, some grade, and then we need to add that grade to the sum. Right? So let me show you exactly how that's going to be done. Let's write the actual program. So let's go back to our compiler. Okay. All right, let me delete this. We'll start from scratch, basically. Okay. So let's start thinking in terms of what variables we're going to need. Okay. I'm going to enter in some number of grades, right? But do I need to keep track, or do I need to memorize, have this program remember every single grade that's entered in? If all I'm doing is just calculating an average, do I need to remember every single grade? The answer is no. All right? All you need to do is enter a grade, add it to the sum. So do I need a bunch of variables for all the different grades that are entered? I do not. All I need is one variable that gets reused. Okay, so let's call that int grade. So our grades are going to be integers, right? We're not going to allow for fractional grades. So I need an integer grade. What else do we need? As each grade is entered, okay, we need to keep track. We need to add it to the sum. So I'm going to create some value sum, and I'm going to set it equal to 0. Okay, and I'll explain why you must set sum equal to 0. Okay, in a little bit. So sum is equal to 0. Okay, and then what else do you need? Well, once you're done, right, what's your average going to be? Your average is going to be sum divided by how many grades you have. Right? So I need to specify how many grades I have. So the way we're going to write this program, right, I want this to work regardless of how many grades someone has. So you're going to ask the user to enter in how many grades they have to enter. Okay, so let's just call that n for number of grades. All right, so and then once you have all that, what is your average? It's going to be sum divided by n. Okay, now once you divide two numbers, that's no longer an integer, right? Averages usually are real numbers. So we're going to do a double AVG for average. Okay, and what's next? Let's think about this. All right. I don't want to, before I even enter any grades, what do I need to do? I need to ask the user how many grades there are so I can set up the for loop correctly. Okay, so that's cout, enter number of grades to be, that's kind of weird, right? I don't want to say enter number of grades to be entered. Let's just, let's just write this as number of grades to be entered. Okay, then I cn to that n, right? That's why we created that variable n. Once I know what n is, now I can set up my for loop. Okay, so remember how the for loop works. I have for, right? Int I equal to 1, let's start counting from 1. Okay, I less than or equal to n. What is another alternative of for I less than or equal to n? I could do I less than n plus 1, right? Because what this is going to do is, this says as long as I is less than or equal to n, then I'm going to keep running through. So if n is 20, right, do I want to keep running, continue running when I is equal to 20? And yes, right, I have to run all the way through and including the 20th grade. But if I do I is less than, instead of less than or equal to, then I could put in 21 or n plus 1, right? Because that says as long as I is less than 21, I'm going to keep going. So what's included in I less than 21? It's going to be I equal to 20. Okay? And then, of course, I plus plus. All right? And actually, let me show you a little something here that I'm going to do. I'm going to put out some message here that says enter grades one at a time. Okay? Because if I do that, right, then the user knows to just keep punching in a bunch of grades. I could do that. If I do that, then inside this for loop, I don't need a C out. I don't want to keep saying enter a grade, enter a grade, enter a grade 20 times, right? What I want to do is say, before I even start the for loop, I say enter your grades one at a time, and then inside the for loop, once the for loop starts, the user knows to just enter in as many grades as they have. All right? So now all I need is a cn. Okay? Grade. What happens as each grade is entered? I am going to add it to my sum, right? So I have to say, this is how you do it. Sum is equal to the old sum plus my grade. So now can you see why sum was set equal to 0 when I first defined it? Because the first grade that's entered, right? If I do sum is equal to sum plus grade, the first grade that's entered, I want that first grade to be added to 0. If I did not set sum equal to 0, and then I try to run sum equal to sum plus grade, then I'm going to get an error message. Okay? It's going to say sum has no value, and you're trying to add grade to it. Right? So what am I adding grade to? C++ doesn't know, if I don't tell it that sum is equal to 0 to start off, C++ does not know that it has to set sum equal to 0. Okay. Here's the worst case scenario. When you create this variable sum, C++ goes into memory and just claims some memory to store that value sum. If there happened to be some number left over in that memory location, it might just simply just go ahead and take that number, right, to start off. Maybe there's a number that's 5,000 that's sitting in that memory location. So now when you enter in your first grade, that grade gets added to the number 5,000, which obviously is going to give you a very strange result. Okay? All right, so that's all I need inside that for loop, right? The user enters in a grade, the grade gets added to the running sum, and that's going to happen, right, for as many grades as the user has. Once that for loop is done, what do? You have to calculate your average. So you say AVG is equal to the sum divided by the number of grades that you have. Okay? And then you can see out average equals, right, AVG. Put in a space there. Okay? End line. Okay, then I return 0. Okay? Close out the program. All right, and let's go ahead and run it. So, debug. Start with the debugging. Let's not do a very complicated example here, of course, right? Let's just put in 5 grades, okay, and then just type in some random values here, 65, right, 72, 88, 48, 96, that's 5 grades, right? If I hit enter here, it should give me an average. Average is equal to 73, okay? All right, 8, 9, 10, 80. All right, so that is the program. Okay, so hopefully that shows you exactly how the for loop works. Okay, and it shows you why you need a for loop. I mean, you do things like this a lot in programming, right, where you're doing things over and over and over. Okay, so for loops are definitely critical. One of the most important things in C++. Okay, so let's go back to our lecture. All right, so that's our for loop. And again, a for loop is used anytime you know exactly how many times you're going to repeat those statements, okay, within the loop. When you do not know how many times you want to loop, then you can use what is called a while or a do-while loop. Okay, these are very similar. Okay, the while loop and the do-while loop are very similar, and I'll kind of explain the subtle difference between these two. Right? But the thing with the while and the do-while is anything you can do with the while loop, you can do with the do-while loop. Okay, they're interchangeable. You just have to make some slight modifications when you use one or the other, and so usually you come up with your own preference. Okay, you will gravitate towards one of the two, and that's fine, right? If you feel like you want to just stick with one of these, that's perfectly fine. Okay. Now, on an exam, you have to be able to distinguish between the two. Okay, but if you're actually writing a program on your own, then it doesn't matter which one you use. All right, so let's start with the while loop. Okay. The while loop is somewhat similar to the for loop, right? But it goes something like this. I write the word while, and then inside these parentheses, I put my condition. Okay, so usually it's going to be some variable. Let's say I'm using a counter again, right? Or so sometimes it's a counter, but a lot of times it's checking some variable that you have. So here's my example. If we're talking about grades, right, entering grades and calculating the average of those grades, I've got this stack of exam papers that I want to just keep entering in. When I get to that last exam, I want to enter that in, and then I have to somehow tell the program that I'm done. So how do I do that? Well, a lot of times you basically have to set up some kind of rule, right? Or kind of come up with some kind of impossible situation. So what I mean by that, right, by an impossible situation in our example is a negative grade. Right? You think about all the grades that could possibly be entered, and you're going to have to ask yourself, what is an impossible grade? Right? And probably 99% of the time, it's going to be a negative score. Okay? So you're going to say, well, I can indicate to the program that I've entered in all my grades, right, when I type in a negative number. So in our example, this would be while grade is greater than or equal to 0. As long as my grade is positive, that's really what this is saying, then keep going, right? Keep repeating. Keep repeating what you're doing, meaning entering a grade and then adding it to the sum. Once a negative grade is put in, then you know it's time to stop. okay, and go ahead and calculate the average. All right, so let's go ahead and modify our program to show the while loop. All right, so I still need this n. Why do I still need n? This number of grades. Because when I calculate the average, right, I still need to divide the sum by how many grades I have. So, except now, n, you're not going to ask for n. Right? You're going to count how many values have been entered. So if I'm setting up n as a counter, what I want to do is set it equal to 0. It's the same reason as why we set sum equal to 0. Because when you define this variable n, if there was already a number in memory, you definitely don't want to start counting from that number, right? If we had the number 5,000 in memory left over from some prior program, then you don't want to say, okay, I'm going to start with 5,000 grades and then count 5,001, 5,002, right? Obviously, you want to start from 0 and count from there. All right, so we have to set n equal to 0. I'm going to delete these C out and C ins. We're not going to ask for n anymore, okay? But we are going to say enter grades one at a time, but now you have to give an instruction. Enter grades one at a time, right? And then enter a negative number when done. Okay? Because you have to tell the user how to finish, how to specify that they're done entering in grades. All right? And now we get rid of the for loop. We're going to use a while. While grade is greater than or equal to 0. Be careful here. Okay? I need to make another change. I'm going to say while grade is equal to greater than or equal to 0. So if I keep this program the way it is now, will it run? Okay? And the answer is no. This program won't even ask for a grade, and it won't even really try and calculate an average. And here's why. I've defined this grade, right? And then, but is there a value for a grade? There's no value for my grade, but so this program runs right into the while loop, and it checks, is grade greater than or equal to 0? What do you think is going to happen? You will actually get an error message that says grade has no value. How are you supposed to compare grade to 0 if grade has no value to start off with? Okay, so here's what we need to do. Where I define grade, I'm going to set it equal to 0. Does 0 have any effect when you try and add it to the sum? No, right? So that's fine. Or when you first check your first grade. Okay? It really has no effect other than allowing this while loop to at least run. Okay, so grade is 0. Grade starts off at 0, so when I first come into this while loop, it checks. Is grade greater than or equal to 0? Yes, it is equal to 0, right? And now it's going to go in and take that value that's now entered, okay, and then add it to the sum. All right, so that's one thing. There's going to be, let me run this for you, and you're going to illustrate why there's something else we need to add to this program. Okay, so this program, the way it is now, it will run, right? It will ask for a bunch of grades, and it will calculate an average, but the average is going to be incorrect. All right, let me just show you that. All right, so we're going to enter in 5 grades, right? So let me make this really simple. Let's put in 5 grades of 50 each. Right, so your average should be 50. Do you think that's what we're going to get? Right, so I'm going to put in now a negative number. -1, okay, to indicate I'm done. And this actually, sorry. Did I mess up here? Let me just rerun it. Okay, sorry about that. All right, so enter grades one at a time, 50, 50, 50, 50, 50, right, negative 1. So I do have an error here. Let me bear with me here. Let's see if I missed anything. Sum equals sum. Oh, n, right? I'm sorry, I forgot about that. One thing I totally missed here. Once you enter it in a grade and it's added to the sum, I need to make sure I note that down, right? N plus plus. Remember what that means? It says take n and add 1 to it. So what is n doing? N is keeping track of how many grades I have, right? So once I put in that first grade, n equals n plus 1 takes that initial value of 0 for n, adds 1 to it. N is now 1. It says, okay, you now have 1 grade, right? When I put in the second grade, it adds another 1 to n, so now n is 2, and so on and so forth. Okay, so that definitely is needed. Okay, I need to keep track of how many grades I've entered. All right, so let me start this again. And let me just, again, use this example of the grades of 50. Right, so 5 50s and a negative 1. If this works correctly, the average should be 50, right? But it's not going to be. So let's check it, right? My average is 41. So why is that? All right, see if you can figure out why our average was not 50. So if you said, right, that negative 1 is counted as one of our grades, then you would be correct. So what happened when I entered in the negative 1 is this. Right? I entered in 50, 50, 50, and then for the very last grade, right, it checked, was that previous grade greater than or equal to 0? Yes, it was a 50, so it's going to ask me for a new grade, right? I entered in a negative 1. Then negative 1 got added to the sum, and then n plus plus basically counted that negative 1 as one of my grades. So n actually became 6. This actually took it as if I had 6 grades, right? And then my sum was then divided by 6. So there's 2 things wrong here. The sum included the negative 1, and then n included that negative 1 as one of my grades. Okay, so how do I correct that? Here's one way, right? You might say one way is to just take back out that last negative 1 that was entered in. So how do you do that? You say sum is equal to sum minus grade, because grade was whatever grade is left in memory is that previous grade, which was the negative 1, right? And then you do n minus minus. N minus minus is very similar to n plus plus, right? It's shortcut for n equals n minus 1. So it takes that n and it subtracts 1. All right, so let's go ahead and run this again. And what you should see is that it now works correctly. I'm going to do 50, 50, 50, 50, 50, all right, negative 1. Average is 50. All right, so that's one way of getting around it. And this is perfectly fine. What is another way? And there's no right or wrong way, guys. I will go ahead and say that. You decide for yourself how you want to handle it. The other way is right inside my while loop, I'm going to put in an if condition, and what I'm going to check for is whether the grade that's entered in is actually allowed. Okay, so if grade is greater than or equal to 0, then what do? This says only if the grade is greater than or equal to 0 am I going to count it in my sum, and am I going to add it to n or count it as one of my grades. Okay, that means when you put in, that means all the acceptable values that I put in, right? This if grade is greater than or equal to 0 is true, so all those values were added to the sum and they were counted, right? But once you put in that negative 1, What does that if statement give you? It gives you false. It says -1 is not greater than or equal to 0, so the -1 doesn't get added to the sum. The -1 doesn't get added as one of your grades. Okay, so let's run this. All right, so 50, 50, 50, 50, 50, -1. That's right. Still get an answer of 50. All right, so that is the while loop. So there's something about the while loop that I want to point out before we go to the do while loop. Okay. In the while loop, right, does the while loop have to run at all? And if you remember what I said earlier about having to set grade equal to 0, right, the answer is no. Your while loop does not have to run at all. Like, let's say I put grade. I mean, not that you would do this, but what if grade were -5 to start with? Will this while loop run at all? Right? So grade is -5, and then you run to this while loop, and before it even does anything, it checks. Is -5 greater than or equal to 0? It's not, so it won't even go into this while loop. It'll just skip the whole while loop. Okay? So the while loop does not have to run, not even once. Okay? So how about the do while loop? Okay? The do while loop is very similar, except this while, this condition of while, where it's doing the check, is moved to the very end. So what I'm going to do is I'm going to cut it and paste it to the end of the brace, okay, at the end of the brace. And then at the beginning, instead of while, you put the word do. Sorry. Up here, okay, I put the word do. So this is your do while loop. Okay, so what's the difference? Now it doesn't check anything, okay, when it first encounters the loop. So a do while loop will always run at least once. Okay? Only after you enter the grade does it check whether that grade was greater than or equal to 0. All right? So I could leave this as is. Do you think this will run? Okay? Yeah, this should run just fine. Okay, so let's go ahead and run it. All right, so 50, 50, 50, 50, 50, and a -1. Average is 50, okay? So why did that work? Let's look at it, right? So I go into this do loop, this do while loop. It asks for a grade, CN grade. I entered in the 50, right? And it checked, is that grade greater than or equal to 0? It was, so it got added to the sum, right? And it got added as my first grade. And then at the end of that, now it checks. Now it goes to the while. It checks, is that grade greater than or equal to 0? It was, right? So it went ahead and repeated. It went back up and repeated. Right? Asked for the next grade, and so on and so forth. Once I put in the negative number, right? The negative number, it checked. Was that negative number greater than or equal to 0? It was not. So it skipped the sum is sum plus grade. It skipped the n plus plus. When it got down to the while, it asked, is -1 greater than or equal to 0? It wasn't. So it never went back up to repeat. It just went down to the average. Okay? So that's what happened. So can you see that these two are basically interchangeable? Right? Here's what you can do if you were using the do while loop. You don't need to set grade equal to 0 to start off anymore. Okay. Oops. I deleted something by mistake there. Sorry about that. Okay. So I don't need at the very beginning here, grade is equal to 0. Because it never even checks, right, for a grade until actually after I entered in the first grade. All right, so the while and the do while are very, very similar, okay? The only difference is the while loop checks, right, whether it's going to run through that loop at all at the very beginning, whereas the do while loop runs through once and then checks. Okay, so we'll have more examples of while and do while loops as we go along in this course. Okay, for now, make sure you understand the difference between the two and how you use these two different loops. All right, so going back to my slides, okay, that was the very last loop, okay, that we have. So your if else, your switch, your for, your while, and your do while, these are all what we call control structures. Control structures are basically commands in C++ that allow you to control the flow of your program, right? They let you decide when to repeat things, when you choose one set of commands over the other, and those types of situations. All right, so those are control structures. Those are very important in C++. They're important in any programming language that you study. All right, they exist in every single programming language. You know, they might differ slightly in syntax, but every programming language has if and if-else statements or something very similar. Every programming language has for loops, while loops, and do while loops. And they're absolutely critical. You cannot write a fairly complicated program without having these control structures. Okay? Once you have control structures, your programs are no longer linear and sequential. Okay? And by linear and sequential, I meant your program just goes from line to line. It doesn't skip around. It doesn't repeat things. Right? It's rare that you have a program like that. You only very simple programs are linear, right? And those programs will be like the type that we wrote last week, where we're calculating the distance between 2 points. Okay? Anything more complicated than that is going to require at least one or more of these control structures. All right, so the next part of this lecture, okay, is referred to as algorithm development. And by algorithm development, right, we're talking about how we design programs. In the simple programs that you're going to write in this class, you could basically think in your head and come up in your head with an idea for how you want to write the program, and then you sit down in front of your computer and just start typing. Right? You start writing the program. You might have to retype certain things. You might have to move some lines around. But these programs are simple enough that you don't really need to plan it in detail before you actually sit down and start typing your program. But how about very complicated programs? Right? If you're working for a software house, right, you're actually developing commercial software that's going to be marketed. It's going to be sold. Right? It's going to be put on a CD or DVD and sold by the hundreds or thousands to people. Those programs are very complicated. Right? So if you're one of the programmers that worked on something like that, you do not sit down in front of a computer and just start typing. Okay? You really need to plan out in detail exactly how that program is going to look like and how you're going to write it. Okay, so that's algorithm development. That's coming up with a basic design for the program. And there are two different ways that programmers use, okay, to develop their algorithms or to design their programs. The first way, okay, is what we call pseudocode. Okay, so pseudocode is sort of what I have been showing you in my written whiteboard. Right? It's basically me saying, okay, if I'm going to write a program to calculate the average, right, of a bunch of grades, then I basically just lay out the major steps. Okay, I don't even need to write this in C++ code or any type of code. All I'm really doing is creating an outline of how my program is going to look. All right, so using that example of using the for loop to ask for a bunch of grades and then calculating the average of those grades, all I do is just list the major steps, okay? And I could use more detail if I want. I could use slightly less detail. It's all a matter of personal preference, right? But the whole idea here is you lay down the major steps, and then once you're satisfied, right, that you've captured everything, then you go ahead and take that pseudocode, right? Pseudo, if you remember, means sort of means not exact, right? It's not exactly. It's half. You know, it's kind of an imitation code, if you will. All right. So you take that virtual code, right? It's not actual code. You take that and then you actually convert it to the language of your choice, whether it's C++, Java, or whatever. So let's write pseudocode for that program, right? It might look something like, I know I need to define a bunch of numbers, right? I need to define int n. I need to define grade, right? Sum, right? Or instead of int, I might say define, right? I write down define, and then define real number, average, okay? Then I'm going to say input n. Then I'm going to have for loop, right? Enter grade, or enter n grades, right? And then I calculate average is equal to sum divided by n, and then output average. Okay, so pseudocode might look something like this. It looks nothing like C++ code, even though I can make it look somewhat like C++ code, right? But it doesn't have to look like code at all. And then what you do is you take this and just say, okay, the first thing I need to do is define integers n, grade, and sum, and then depending what language you're writing in, you actually write it in proper code, right? And you just go through this line by line and convert every one of these lines to actual code. How often is this used by professional programmers? I would say not very often, right? Because to do something like this, you pretty much are doing a lot of writing anyway, and you're writing out like almost all the major steps, right? So why bother doing this and then converting it to code, right? You might do this if you're writing in a language that's very difficult to code in. So you write it in shorthand, or you do it in something that's very simple to read first, all right? And then you actually sit down and put it in actual code. But a lot of programmers don't do this because it actually requires that you know exactly what your program is going to look like. What is more commonly used among programmers is to do something that's a lot more visual. Okay, and that's creating something that's called a flowchart. Now, you might have heard the term flowchart before. Okay, but a flowchart basically uses symbols and arrows to indicate exactly how your program is going to flow, how you move from one step to the next. Okay, so flowcharting is something that's not just for programming, right? It's not just for depicting or displaying what a program looks like. It can be used to kind of lay out how you're going to solve any type of a problem. Okay? You could use flowcharts to show how you're going to work out, say, a physics problem. Right? So flowcharting is something that has real use, real application in a lot of different cases. is it going to be a critical part of what you do in this class? Right? My answer to that is no, because the programs you write are going to be fairly simple. To be perfectly honest, the reason that we are teaching flowcharts in this class is Virginia Tech says that it's a requirement. Okay? They say if we want Engineering 126 to transfer for our students, then we must teach flowcharts. So that's the only reason we're teaching it. Virginia Tech, for whatever reason, thinks it's one of the most important things that engineers should learn. So, you know, it is a good thing to learn, okay? But as far as whether it's critical for this class, no, other than the fact that it's a required part of the curriculum, so I have to test you on it in one of the tests at least, okay? So let's go through exactly how flowcharts are going to work. The first thing that's required when you start using flowcharts is you have to learn all the different symbols that are used, okay? So the first basic symbol is to indicate the start and the end of your program. So that's by using an oval. Okay, so and then you draw an oval and you put the word start or begin, right, to indicate that that's the start of your program. Then you use an arrow to point to the next step, right? At the end of your program, you use another oval and you put end or finish or whatever you want, right? And there's an arrow pointing to it, right? And then there's a lot of the rest of your program kind of goes in between, okay? So one of the nice things about flowcharts is there's no rule that says you have to do things a certain way. Okay, so you can make your arrows flow in any direction you want. You could start at the top, go to the bottom, right? You could start at the left, go towards the right, and then zigzag. I mean, it doesn't matter how you want to do this because you're using arrows to indicate how you move from step to step. Okay, so that's the nice thing. All right, so what's the next thing? The next thing is basically any type of calculation or memory operation, okay, is a rectangle. So you would use rectangles for defining variables. You would use it for any calculations, right? And those are probably the main things, okay, for using a rectangle. Okay. The next symbol is a parallelogram, okay, or a trapezoid, I guess you could call this. All right, this is input-output. Anytime you're doing a C-out and or a C-in, you use these, okay? Next is the diamond. This is anytime you're making a check, making a comparison, right? If you're checking whether a variable is equal to some value, whether a variable is greater than, less than, greater than or equal to, so on and so forth, right? Anytime you're making one of those checks, you're going to use this. So when do you make checks? Think back to all the control structures that we just talked about, right? When do you make checks? Like if I'm checking whether x modulus 2 is equal to 0, right? If I'm checking that, right, when would you ever do that sort of a check? You would use it with your if or if else, okay? You would use it in your while. Remember, in the while condition has a check in it, right? The do while. And then you might want to say a for loop. Remember, the for loop has a check. You're going to check whether that counter still fits within the range for your loop, right? But the for loop actually has its own symbol, right? So, but anyway, the diamond is very important, okay? It's for all your comparisons, all your checks. And lastly, then, the for loop, okay? The for loop, we use this hexagon. Okay? And the for loop has two parts to it. I'm sorry, not 2 parts, 3 parts to it. So I'm going to break this up into 3 parts. All right, so what happens is your program flows in, okay, and that's where you define your counter, int I equal to 1, for instance, right? And then right below, and then this is where you make your check. You check, is I less than or equal to 20, okay? If it is, right, you do one thing. If it's not, you do something else, right? And then at each iteration, this shows how you increase I, or sometimes how you decrease I, okay? So that's your for loop. All right, so let me show you how all these different things are used, okay? Let's take all the programs that we've written up to now. And before we do that, actually, let me tell you what's required then, as far as this class is concerned. Okay, you will be required to memorize all these symbols. You will be required to draw some flowcharts. And on an exam, if I were to test you on the flowchart, right, it will probably be in one of 2 types of problems. In the first type, I will give you a program. Okay, programs are written out, and I'll tell you, create the flowchart for this program. Okay, the other possibility would be the reverse. I give you a flowchart, and then I say, write the C++ program for this flowchart. Okay, that's just to demonstrate to me then that you understand how to go back and forth between a flowchart and a program. If you were a professional programmer, you would only go in one way, of course, right? You would sit there, right? So the nice thing about a flowchart is that it allows a programmer, before they even start coding, to sit there and kind of draw out how their program is going to look, okay? It gives you a very visual representation of the program, and once you've got it all drawn out, then you convert it to C++ code or whatever language you're using, all right? Okay, so let's start with a easy case. Okay, let me erase it. All right, the very first program that we wrote last week, right, was calculating the distance between 2 points. Okay, so let's start with that. Let's convert that to a flowchart. So start, if you remember, we then define our variables, right? Double x1, y1, x2, y2, all right, so on. Let me leave out some details here. I don't have a lot of room, right? Then the way we modified that program was we asked the user to put in x1, y1, x2, y2, right? Then we calculated side 1, side 2. Notice I'm combining these calculations into one, right? That's all up to you how you want to do this. Some people would combine them all into one. Some people might do a separate box, right, for each calculation. It doesn't matter. Okay? Distance equals whatever. And what do we do after we calculate the distance? We output it, right? So that means you output distance, and then that was the end. Okay? Very simple. How about the flowchart for the first program we wrote today, right? The two if statements, or actually let's just do the if else. Or, well, no, let's do the two ifs, right? We were checking whether a number was even or odd. So start, right? We defined int x, excuse we input a value x, right, ask for that value, and then what did we do? We first checked, is x modulus 2 equal to 0? And this is how this is going to work. Remember, the if, right, has two conditions. If it is, we put a yes here, okay, or you could put true. If it is, what did we do? We output, right, output that it was even. Output x was even. If it's not, then what did we do? We checked. But even if it was true, remember, we had to go here and check whether x modulus 2 was equal to 1, right? And if that was equal to 1, we output that it was odd, and then this had to go all the way down here as well. Then we ended. Okay? So you notice what these arrows are doing. They're indicating where you go after each step. Okay? So actually, you know what? Let me do this a little better. Okay? Let me redo that one. Okay. So we start. We define an integer x. We input a value for x. Okay. Then we went to the if, right? We checked if x modulus 2 was equal to 0. If it is, right, we output that it was even. And then what did we do? If it's not, we skip that, right? And then both of these went to, and then regardless of whether we use the output or not, right, we went and checked whether x modulus 2 was equal to 1. If it is, let me put that here. If it was, we output that it was odd. Right. If it's not, right, that's no. Right. Both of these end up being the end of the program. Okay, so that's the flow chart for that. Now, how do I change this so that it became the if-else, right? So that the if-else replaced the two ifs. So start, let me just use st, right? We still defined our int x. We still input x. And now we go to the if, right? Is x modulus 2 equal to 0? If it was, we output that it was even. But now, if it was not, what happened? We output that was odd, right? And then, regardless of which output we had, that was the end of the program. Okay? So that's how the if-else looks like. The next program, okay, was so let's just do the nested. Remember all those nested if-elses for the grades, right? Determining whether a grade was A, B, C, D, or F. Okay, so we start it. we had integer grade. We input our grade. Right? And then we went to check whether we had an A. So grade greater than or equal to 90. Notice I don't need to do this in C++ code, right? Because in fact, a lot of times you don't want to do this in C++ code, because that way you could give this to someone and, you know, tell them convert it to any language of your choice, right? So it depends on the situation, of course. Okay? All right, so if this were the case, we output A, right? If it's not the case, so this was yes, right? If it's not less than 90, we went and checked whether it was between 80 and 90. If it was, we output B, right? If it's not, we checked whether it was 70, right? Let me skip some steps there. C, right? Not, we checked whether it was 60 less than or equal to grade, less than 70. If it was a D, otherwise it was an F, right? And then all of these, once you print whether something was A, B, C, D, or F, that was all the end of the program. Okay? So that's that. Okay, it is a little messy, but hopefully you see what happened there, right? So notice, so what the important thing to point out here is what this is showing is that anytime I have a yes, right, I print out the grade and it goes right to the end. I could skip the rest of all these stuff. Right? If I had A, I could skip all of this. After I print out the grade of A, I go right to the end. Okay? All right. So next, right? The one where we asked for how many grades we had to calculate the average of, and then we used a for loop, right, to ask for those grades. So that's start. Right? We need int n grade sum equal to 0, right? Then we had a double average. Oops. We're going to ask for how many grades. Input n, right? And now we go into the for loop. So let me show you how this for loop is going to work exactly. So we start with I equal to 0, right? And then we check. As long as I is less than or equal to n, right? So we check, is I less than or equal to n? If it is, what do? We ask for a grade, input grade, right? And what happened to that grade? It got added to the sum. That's a calculation. Sum equals sum plus grade, right? And then it repeated. How did it repeat? This flows to here, which is I plus plus, which is then you add 1 to I, right? So I starts at 0, you check whether 0 is less than or equal to n. If 0 obviously is, right? I'm sorry, it wasn't 0. We use 1 in our example, right? So I starts at 1, and then we check, is 1 less than how many grades you have? Of course it is, right? So you ask for an input, you add it to the sum, and then you go back, you add 1 to I, and then you check again. Is it less than the number of grades? Yes. So you can see, right, that this is the loop. Let me show that in blue here. This is the loop. Okay, that's the loop. It just keeps looping, okay, until I is no longer less than or equal to n. Okay, and once I is no longer less than or equal to n, that's this no here, right? No. What happens? We calculate our average, which is sum divided by n, right? Then you output your average, and that's the end. Okay. All right. Now, how do I change this, right, into the one where we had the while and do while loop? So this is probably the most important. These are the two most important flowcharts that we're going to have, okay, for this lecture. So let's do the while loop. I have my start, right? I define my variables. Let me skip the actual variables, okay, because this is hard for me to write on the white screen. Define my variables, okay, and then I immediately go and check, right, whether grade was positive. As long as it was positive, we ask for another grade, right? Input grade, and we added it to the sum. Then we had n plus plus, right? And then it flowed back. This flowed back here. So that's the loop, okay? As long as grade was greater than or equal to 0, we just kept looping. So again, let me show you the loop, right? The loop flows that way, right? That's the loop, okay? Once grade is no longer less than or equal to, no longer greater than or equal to 0, that means we entered in a negative value. Then remember, we took out the last negative value, sum equals sum minus grade, and we did an n minus minus, right? Then you calculate the average, then you output the average, and then that was the end of the program. This will be much easier for me to do on the blackboard, but hopefully you get the idea, all right? I did post up on Blackboard, okay, under course documents, I believe a couple of examples of flowcharts, okay? So use those, take a look at those. Those might be a little easier to make out than what I'm doing on this lecture, right? If you have any questions, this is the third lecture. I should be seeing everybody in person real soon. If there's any confusion on these flowcharts, bring it up to me when I'm back in the country and we have our in-class meetings, right? And we'll go through this again on the board. Okay? All right, but if nobody brings it up, then obviously I won't know that there are any issues. Okay, so again, note down all your issues, right, with my video lectures, and we'll try and redo some of this confusing stuff, or the stuff that's hard to make out once I'm back in the States. All right, so there's our while loop. Okay, how do you make out that this is a while loop? Okay, it's pretty subtle, as I say. So go back to this blue loop that I've kind of marked up here. Right. Notice within this loop, right? First of all, you have to identify this as a loop, right? By following the arrows, you can see that the arrows fly back, right? So by looking at that, you know that this is a loop, right? But you also notice that the check, this diamond, right, where you're making a comparison, is at the beginning of that loop. Okay. That's what sets this apart as a while loop instead of a do-while loop. Okay, so in the while loop, the check that you make is at the beginning of the loop. If this were a do-while loop, okay, it would change ever so slightly. You have your start, you define your variables, and then you go right into asking for the grade, right? Input grade. Then you go and added it to the sum. Sum equals sum plus grade. All right, then you had an n plus plus. Then you checked. Was grade greater than or equal to 0? If it was, you flew back here and asked for the next grade, right? If it's not, then you subtracted out the last grade, right? Sum equals sum minus grade, right? Then you do n minus minus. You output the result. You calculate the average, I'm sorry. The rest of this is the same as the previous. Right? You calculate your average. You display your average. Then that's the end. So here's the loop, right? You see how the arrow flows here and all the way around, and it just keeps going, right? And then what makes you certain that this is a do while and not a while? It's that the check is at the end of that loop. Okay? So this is how flowcharting works. Okay, and the way flowcharts are used, and if you were a programmer, right, is you would come up with this, and programmers, right, once they get good enough with using flowcharts, they would be able to take this and convert it directly into a program, into a C++ program in our case. Okay? So learn the different symbols, right? Make sure you understand the differences between the while and the do-while loop. Make sure you understand how to create these flowcharts, right? And again, you're going to go back and forth. Make sure you could create the flowchart out of a program that I give you, or make sure you could create a program out of the flowchart that I give you. Okay, so we will talk more about flowcharts if necessary once I'm back in the States. Okay, hopefully this will be the very last video lecture. This is the 3rd week, right? I hope to be back in person for the 4th week. So look for an announcement before a few days before I'm back in town, right? If there is a need for a 4th video lecture, I will announce that as well, and that will be posted up on Blackboard. But hopefully, this will be the last video lecture. All right, so save your questions or anything that needs addressing in person for until I'm back. And anything that I could answer for you via email, please just go ahead and email me, and I'll get back to you as soon as I can. All right, so this is Engineering 126, Week 3, the end.